Okay, here's a couple questions I got from one of my students, and they are working on a review right now for a test, and they sent me these two. And this is for a delta H question, and this one is for figuring out a formula. So this first one, it says at a constant pressure, what is the delta H for the reaction? And it gives you the delta H if a certain combustion of ethane, like a certain mass of ethane, is combusted. So what we're going to do with this is we're first going to take this 38.2 grams of ethane, and we're going to divide that by the molar mass, which is about 30. So when we do that, what we're going to get is about 1.27 moles. So with that 1.27 moles, we know that it releases 1981 kilojoules of heat. So we can take this now, and we can set up a ratio. In the problem, if you look at this 2 right here, that's saying that if 2 moles of ethane are burned, then, whatever here happens. So 4 moles of CO2 are produced and 6 moles of water are produced. So we can take that and set it up in a ratio. So if 2 moles are combusted, then we're going to have a certain amount of heat that's going to be released. So if we set it up as a ratio, we'd have 1981 times 2, and then divide that by 1.27. And if 2 moles are combusted, that means about 3,120 kilojoules of heat energy will be released. This second one's going to take a couple steps also. So an unknown organic compound is 41% carbon, 3.5% hydrogen, and 55% oxygen by mass. So when you're given these percent by masses, what you can do is assume that this is out of 100 grams. So if it's out of 100 grams, then we have 41.4 grams of carbon. We have 3.47 grams of hydrogen and 55.1 grams of oxygen. So now you can solve this in the way you'd solve for percent mass. So you divide by the molar mass, divide by 12, divided by 1, divided by 16. And what you're going to get roughly is going to be 4.5, 4.5, 4.5. Now, if these were different numbers, if these were not all, roughly the same, you would divide by the lowest one. But they're all 4.5. So we're going to have 1, 1, and 1, which means that in this formula, it's going to be C2H6. And these X's right here, they're going to be 1s. And that's for the empirical formula. But we want to figure out the molecular formula. So they tell us that a 0.03 mole sample is 3.48 grams. So again, just like in the first problem, we can set this up as a ratio. So 0.03 is 3.48. So then therefore, 1 mole would be a certain mass. So you'd have 3.48 divided by 0.03, which would give you 116 grams per mole. So now we need to figure out which of these formulas give us a mass of 116 grams per mole. Well, it's not going to be A, because if you look at the coefficients, it's 331. We're looking for something with the same. So if we go to B, then we add up 12 times 4 plus 16 times 4 plus 1 times 4. And then we will get 116. So that's going to be our formula right there. C4H4O4. That's going to be the molecular formula. The empirical formula would be CHO.